Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.
Welcome to ARC Smart City Viewpoints. I'm Jim Frazer. Today we'll be speaking about the IEEE P2784 Smart City Planning and Technology Guide. I became involved in this standard a little over a year and a half ago after doing quite a bit of standards development work for the US DOT and NEMA and the Department of Energy and some other organizations. As I became involved, I led the effort to create the foundational outline for the document. Soon after, the leadership drifted away and disbanded, and we're now regrouping under myself as chair, Larissa Paredes-Muse as vice chair, and Edward Fiddler as secretary. So after a February kickoff meeting last month in Orlando, where we had close to 100 people, we're now scheduling monthly online meetings, and we urge anyone who's listening here or anyone in your ecosystem to join us. And it's a very well-needed standard. So what's really in this IEEE P2784 effort? Well, I'll get started by just reading the definition and the guiding document that enables this standards working group. And it's this. This guide will provide a framework that outlines technologies and processes for planning the evolution of a smart city. Smart cities and related solutions require technology standards and a cohesive process planning framework for the use of Internet of Things to ensure interoperable, agile, and scalable solutions that are able to be implemented and maintained in a sustainable manner. This framework provides a methodology for municipalities as well as technology integrators to use as a tool to plan for innovative and technology solutions for smart cities. So you can see it's a planning guide. And it leaves to other standards, other IEEE and other NEMA standards, NIST standards, much of the technology interoperability, API type standards. So in simple language, it's a cookbook. It's a quick start guide. It's essentially a recipe. It's a plan to qualify and quantify what to do first, what to do second, what to do third, and perhaps even more importantly, what not to do. More formally, it could also be entitled as Smart City Systems Engineering for the Non-Systems Engineer. So in the sections of the outline that we've voted upon within the group, it starts with a problem statement. And the problem statement really describes the conundrum that the smart city ecosystem finds itself in. In that, there's a huge range of very compelling, powerful solutions with short paybacks. However, the adoption rate doesn't come close to even the most conservative forecasts. And much of it, as we've evolved in this industry, can be drawn to the fact that the user needs of the customer are not being fulfilled. Not only are the needs not being fulfilled, but in many cases we don't really know the customer very intimately and don't know many of their needs. So we're finding that out. So that's the problem statement. We'll talk about how we better use these very powerful technological solutions to address the needs that are to be extracted out of a broad community. Then in section 2, it's really a foundational backgrounder where we include a discussion of broad societal topics like the 3 pillars of sustainability, meaning enhancing the environment, enhancing human quality of life while doing those first 2 with a reasonable economic payback. Also in section 2, the backgrounder is definitions and discussions of terms like resilience, which is a response to a short-term impact to the system. Then in section 3, we have a detailed discussion of the 5 groups of human factors that really impact smart city applications. And I won't go into all of them. They're quite numerous. In successive podcasts, we'll touch on these. But the 5 groups are social issues, social human factors, technological human factors. As we know, technology is changing day by day and only in a faster and faster way. Economic factors. As we know, public agencies increasingly are finding budget limitations being a limiting factor on many of their projects. Environmentalism, including CO2 emissions, farmland. There's a range of very important factors there. And there's also the political factors. What type of policies do you want your smart city to adhere to? So those are the large 5: societal, technological, economic, environmental, and political human factors that are discussed in section 3 of the IEEE P2784 standard. In section 4, we've entitled it as Managing the Planning, Design, Operations Process over the Full Life Cycle. And not surprisingly, we've discussed this in previous podcasts, that this really is where we embrace the systems engineering process as used by the U.S. Department of Transportation, the Department of Energy, NASA, and many others. So this is where you define your stakeholders, your stakeholder communities, number 1. Number 2, you extract their user needs in a narrative, meaning citizen, what would you like to fix in your city if you were in charge? Once you define all your stakeholder communities, from perhaps the bicycle community, the downtown business community, elected leaders, taxpayers, special tax districts, adjacent public agencies, and you extract all their needs, then you need to collect them into a list of consensus-based needs. And then once you have that consensus-based need, that really is your foundation that will drive your project, the definition of your project. And once you have those consensus-based needs, you would then evolve them into, or refine them more accurately, into measurable functional requirements. And once you have these measurable functional requirements, this would be your engineering units, a legal numerical range for that specification of your project. And the collection of all of these together can become an RFI or an RFP, or even a product specification for a supplier. And then lastly, in section 4, managing the planning, design, operations over the full life cycle, is applying test plans. And you could think of test plans as guardrails that keep you focused and on track and on the right path, the right road, to fulfilling and satisfying those consensus-based needs, while not allowing any other requirements to creep in to the project as well. So that's section 4. Within section 5, we discuss the 9 traditional legacy applications that many public agencies address. And we've covered this in a previous podcast, but I'll just list them quickly. The built environment, so that's buildings, everything from schools, firehouses, municipal buildings, city-owned hospitals, all police stations, all are in the built environment. And it also includes all of the subsystems that might be in that building. Camera systems, HVAC, security systems. The next application is energy. Many cities and counties are own municipally owned utilities and actually own electrical distribution infrastructure. So do rural electrical co-ops. So in that energy domain, that includes municipally owned substations, distribution equipment, meters, down to even street lighting. The next is telecommunications. This might be publicly owned, it might be privately owned, but robust telecom infrastructure, broadband, is important for economic vitality. So that's number 3. Transportation. Transportation includes all of light rail, bus systems, as well as some of the newer modes of transportation, of scooters, Uber and Lyft, and various other modes. That's number 4. Number 5 is water and wastewater. Water is becoming an increasingly pricey commodity around the world, and both the quality and quantity of water is very important, as well as the management of wastewater. And F, health and human services is very important, including telepresence for healthcare providers. Public safety, think police, fire, and EMS. In many areas of the country, fire and EMS people strive to a 4-minute response time or less. That can greatly save lives. It includes police body cams and a range of other IoT-enabled hardware, fixed and mobile, like gunshot detectors. But then we have online payments and finance. Online bill paying for a city can yield very dramatic rewards with extremely short payback, particularly when you may have use applications to drive revenue in other verticals within the city. And I know in a previous podcast we used the example of registering in a city softball league with your address may trigger an address change where you get billed for a driver's license update. And then, of course, the last one in terms of applications, number 9, is waste management. Refuse continues to build, and increasingly waste management and landfills and burning are not looked on as optimum solutions. And there are a range of technologies, including methane generation, that are very encouraging in those domains. Now, there are underlying those 9 applications of buildings, energy, telecom, transportation, water and wastewater, health and human services, public safety, payments, and waste management are 7 technologies. Those include instrumentation and control, connectivity, interoperability, security and privacy, data management, computing resources, and analytics. And I won't go into much detail here because I know we've covered these in detail in a previous podcast, but they are all important. The one I think is probably under discussed is interoperability, where for plug and play and for future proofing, you do want interoperable systems so that everything can become, even the largest system can become a component of an even larger integrated system. Then in section 7, we have cross-cutting issues. And one of the most important there is cybersecurity. Cybersecurity crosses all of these technology domains and all of these applications. And is not only a technology solution, but it's a human solution too. Humans need to be trained to maintain cyber secure best health practices. In section 8, we have related standards. This is where you go for more specificity, for true engineering guidance on if you want to apply some of these principles. So there's resources in there from the Illuminating Engineering Society and their Roadway Lighting Committee, from the American Association of State and Highway Transportation Officials, from the IEEE itself. There's a large number of references there in terms of protocols, smart city standards. NEMA is referenced quite a bit. We reference the Instrument Society of America, because a number of their standards do touch on water and wastewater and process control for public agencies. And NIST has a number of references, including their cybersecurity framework, which really is foundational to anyone's cybersecurity efforts. Then lastly, in section 9, we have a Where to Learn More section. And among the most important there is the US Department of Transportation's Intelligent Transportation Systems Professional Capacity Building Program. This is up to an 80 courses that are anywhere between 90 minutes to 2 hours, that are all eligible for professional engineering CEUs, for PEs. And it really follows a college course syllabus with 100, 200, and 300 level courses. It does include much verbiage on systems engineering, and you could think of it almost as a companion piece to what the IEEE is attempting to do here with P2784. So that's a great place to learn more. So before we wind up, again, I'll just walk everyone through the proposed sections of this new standard. So number 1 is the problem statement. Section 2 is a backgrounder that includes discussion of broad societal topics like sustainability and resilience. Then in section 3, we have a detailed discussion of the 5 groups of human factors, with actually there's about 100 human factors in total across those 5 groups. Then in section 4, we have managing the planning, design, operations over the full life cycle, which can be restated as systems engineering for the non-systems engineer. Then in section 5, we review the 9 legacy applications that most public agencies deploy. In section 6, we discuss the 7 technologies that are impacting all of those 9 applications. In section 7, we discuss cross-cutting issues like cybersecurity. In section 8, we discuss related standards. And in section 9, we have a section that's where to learn more. So I thank everyone for attending today, and I would certainly welcome your support and participation in the IEEE P2784 Planning and Technology Standards effort. As I said up front at the beginning of this talk, we meet once a month online, and we do appreciate and require participation from a broad amount of stakeholder communities. So whether you're an end user public agency person or a technologist with a supplier or a consultant, we'd love to have you participate with us. So with that, I thank you very much for joining us today, and I look forward to having you attend future Smart City Viewpoints podcasts. Thank you very much.
Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.